So this is the planetary distance calculator at exploratorium.edu. I'll put a link in at the end of the video. We'll be looking at the distances to the planets from the sun, and that's just a radius for the ecliptic plane. So if you picture the sun in the middle, it's just the distance from the sun out to Pluto at their average distances if they were aligned. And the ecliptic plane is twice that size, of course, with the sun in the center. So we won't be looking at the sizes of the planets at all. If those were to scale, they would be very small in this case, because I'm restricted to limited space, and 1062 for the distance from the sun to Pluto is about a pretty reasonable limit, I think. So assuming a 3-inch diameter of the sun, we'll still get a good picture of radius for the ecliptic.
Lennon, is that 50 feet, your rope?
Yeah.
And Ava, is that 100 feet you got right there?
Yeah.
Here we are scouting the bike path in Brunswick. Our purpose is to walk from a 3-inch diameter sun to Pluto in real time. So you remember when we stood here before and I got a bridge view for no apparent reason? I think we're gonna do this on the train tracks. Crayons for the pavement, 100-foot rope, 50-foot rope. I'm quite glad that this inspiration just hit me. I was a little worried about weirding out pedestrians and dog walkers. So here's your distances from a 3-inch diameter sun in feet. Mercury, 10. Venus, 19. Earth, 26. Mars, 40. 22, Jupiter, 139. Saturn, 256. Uranus, 515. Neptune, 808. 11, and Pluto, 1062. 12. So here are the train tracks. They curve pretty quickly there, but they're pretty straight over there. We'll see. What we're going to demonstrate with this scale model for distances is that with a 3-inch diameter sun, it takes 7 minutes to walk to Pluto, at least at my walking pace. Again, we don't have a scale for the size of the planets, but we will get a good sense of the distance. Indeed, it was quite fortunate to stumble on this area, and it reminds me of the kind of places that I would find as a kid in my hometown. So big kudos to all of us participating in this project, including myself and all of you watching, for making it possible to see this. I wouldn't doubt that I'd actually get my bike going up here. Relevant thoughts, though, while we're standing here. I kind of seized on this because the whole time we're looking at doing this, I was wondering what people would think on the bike path, and kind of whether I should go to City Hall or something and just mention that I'm doing it. And second of all, so this is great, but second of all, it looks like there's maybe a chance for another straightway here, but I thought it would be interesting to still integrate the bike path by going over it, going over top of it. And now, the moment of truth. We will walk in real time to the 3-inch diameter sun from Pluto. Alright, I don't know if it's even legal for me to be here. Now, I'll just keep the camera on, we'll go. Now I'm going to walk back. Because we ended up out on the bridge, I'm going to abandon the original idea of using those rocks, because it's I don't want to put rocks out here on the bridge, of course. So that's one adaptation. Make sure I don't get distracted and miss Pluto. I mean Neptune here. That's one thing that changed. The other thing is I didn't use the 50-foot rope because it's a 30-foot tape measure, and so that's pretty straightforward to use that to get the addition and subtraction that I needed from the 100 markers that I used the rope for. And once I got on the bridge, as you could tell, I was just counting by these rails that are 10 feet each. So that was good. It'll be a little embarrassing if I miss Neptune. Oh, good. Just as I say that. Okay. So here's Neptune. Remember where we started. Unfortunately, I didn't put some big markers. So here's Neptune. And remember, we don't really have the means. Oh, it's windy. I'm sorry. We don't really have the means to get small enough to have those tiny planets. But as you remember, they're really tiny compared to that 3-inch sun. So let's just look at that and think about that scale. Pluto's way out there, just minuscule, like a pin, like the prick of a pin. And here's Neptune. In fact, let's do a review of those measurements when we get back, kind of try to match those concepts together. It's really windy. I don't know if that is enhancing or detracting from your experience here. So let's get a better clip going. I was a little worried that the markings would be difficult to see, but let's see from Neptune that wasn't a problem. So yeah, thinking about the vastness of space just in our neighborhood, just locally here, orbiting around the sun, it's absolutely mind-boggling. If you kind of look over there and think that Earth is like, around that bend, it's pretty cool. It's pretty crazy, to say nothing of, getting to the nearest star, or thinking about galaxies and then superclusters. So here's Uranus, and you could get a sense of the space that we've traveled just because if you look at the river, which is not a trickle, we're almost all the way back to the shore. So Uranus is right here. And then the distances get smaller as we are closing in on the sun. And you know what? Let's leave the rocks for the rocky planets. Isn't that cool? We can do that. And interesting enough, the gas giants will end up being here over the water. I guess. That's pretty cool. Yeah. Although I guess Jupiter's going to make it across the path. So let's take a look. A lot of rocks in the inner solar system, including the asteroid belt, of course. So, yep. Getting that sense of just a total paradigm shift to the gas giants as you get out there, simply in that the distance gets so vast, doubles distance almost for each next planet. So here's Saturn. That also gives you a sense of how huge they have to be to stay in their orbit out there. And we keep going. Now, lest this long, boring clip at the end here seem like it didn't do much, I really actually wanted to culminate things with this long shot, simply because it gives us this sense of traveling the entire way. Because the point I'm looking to make is that it is a long, long way. Here's Jupiter. Great. And then they get closer. Still extremely far away when it comes to, if you think about what a tiny space we occupy right here. So here's Mars, closing in. Gravity's getting stronger. Sky's getting brighter by far. Look at how close we are to Mars. There's Earth right away. And given that we've gone so far, look at how close now. And this is 7 months for us traveling in a spacecraft that we have built. Humans can't. Humans haven't been able to do it yet. So that's sending our robots. Same deal with Venus. We're looking at very very short distance here. And then right to Mercury. Lickety split in a snap, no problem. And then the sun. And so we're here. We've got all that distance. So one last time, if we look at the distance and think about how small the planets are and how far away, it just gives us a little bit of a sense of how small we are ourselves. So after this grotesque shot of my finger getting in the frame, let's review again the distances from a 3-inch diameter sun in feet. Mercury 10, Venus 19, Earth 26, Mars 40, Jupiter 139, Saturn 256, Uranus 515, Neptune 808, and Pluto 1062. And remember, we only looked at the radius. The diameter of the whole ecliptic plane for a 3-inch diameter sun is 2,124 feet. Thanks for watching.